Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Yesterday, in fact, I'm recording the same day, but we did that. I posted that yesterday about solving a system of linear equation using substitution. And then we said that today we are going to do elimination, and tomorrow we'll look at how to graph them and solve graphically. So, what is the method of elimination? Remember last time we said we are going to substitute. So if I look at, I'm going to do only the odd numbers. So since there are too many and they are similar, and I have to just do a couple of like word problems after that. So I don't want it to be very lengthy. Remember last time we said I could substitute, since in fact, in this case, I have the coefficient of x in the first and the second equation is 1, and the coefficient of y is 1 and -1. So I could have used either one of those, and x and substitute, or y and substitute, and solve with substitution. However, there is a more clever way if I see something like that. What do I mean by like that? I see the same coefficient for x and the opposite coefficients for y. So if I'm going to call this equation number 1, and this is equation number 2, and see what happens if I do equation 1 plus equation 2. See how easy it would be? Let's do it. X plus x is 2x. Y minus y is 0. And 2 plus 4 is 6. Dividing by 2, I get x equals 3. Wow, it took 5 seconds. Yes, because the coefficients of x and y were the same. Somebody else would have told me, can you subtract the bottom from the top? I would say x minus x is 0, and y minus negative y is 2y, and 2 minus 4 is -2. So 2y is -2, which means y is -1. So I could have done it either way. But usually, once we find x equals 3, we substitute. We say then, substituting in either equation, it doesn't matter. In 1, for example, we get x is 3 plus y equals 2. And then I subtract 3 from both sides, and I get y equals -1. So x equals 3, y equals -1, and much faster than substitution in this case. We move to number 3. The x's are different, so one of them is 2, the other is 3. We can do it, but it would be a lot of work. Do you know how? Think about it. These don't equal each other. So how do I make them equal each other? I find the least common multiple of 2 and 3, which is 6. And I say, how do I make the top equation 6x? I multiply it by 3. And how do I make the bottom equation 6, or -6 if you want? I multiply it by 2. So when I do that, I multiply the top by 3. I'm not going to solve it like that, but I'm going to show you. I multiply the top by 3, I get 6x minus 3y equals 12. I multiply the bottom by -2. So I end up with -6x, positive 2y, and positive 4. And now it looks something like that. Adding equation 1 to equation 2, 6x minus 6x is 0. I get -3y plus 2y is -y, and 12 plus 4 is 16, so y is -16. Did I do it correctly? Oh, -4, I'm sorry. You multiply the bottom by -2. So I get negative y equals 8, so y is -8. But it's much easier to say, oh, the y here is negative and the y here is also negative. So if I subtract one of the equations from the other, so for example, here it's better to say 2 minus 1, but let's do it equation 1 minus equation 2. 2x minus 3x is negative x. Negative y minus negative y is negative y plus y. They cancel each other. And 4 minus 2 is 2. Dividing by -1 or multiplying both sides by -1, you get x equals 2. Then substituting in either, say, this time in 2, since the previous time we substituted in 1. I get 3x, so 3 times 2 minus y equals 2. 6 minus y equals 2. I'm going to subtract 6. X equals -2. What am I doing? Adding 6 to both sides, I'm sorry, I get negative y equals 8. And then I divide by -1, or I multiply by -1, it doesn't matter. I will get y equals -8. So the answer is x equals -2 and y equals -8. And again, we didn't use a calculator to do that, but we can, and we can check either equation. Now, let's move to number 5. Here we have a problem. I don't have the same coefficient for either the top, for the x's or the y. But what can I do? Yes, least common multiple. Coefficient of 1, coefficient of 3. So I can multiply the top equation by 3, or better, by -3. So the top will have -3x and the bottom would have 3x, and I add them up and get done with it. Or I have a -2 here and a -1. Common denominator is 2, or least common multiple is 2. So, or -2, it doesn't matter. So I'm going to multiply the bottom equation by 2 or by -2 and add them up. So if this is equation 1, let's make it within circles. I'm going to say -2 times the second equation will give me 3x becomes -6x. Negative y becomes positive 2y. And 2 becomes -4. So now I can call that 3 or 2 dash. Let's call it 3. So you see, equation 1 has -2y. Equation 3 has positive 2y. So if I add 1 to 3, I will get x minus 6x is -5x. -2y plus 2y is 0. 3 minus 4 is -1. Dividing by -5, I get x equals 1/5. So substituting, say in 1, I get x, which is 1/5, minus 2y equals 3. Subtracting 1/5 from both sides, I get -2y equals 3 minus 1/5. So I can take a common denominator of 5 and say 3 is 15 over 5 minus 1 equals 14 over 5. And finally, I divide right and left by -2. This becomes y and that becomes negative 7/5. So x equals 1/5, y equals negative 7/5. And then I can use my calculator to check that out. I can check, say, the first equation, x, which is 1/5, minus 2y, so minus 2 times negative 7/5, right? I get 3. So it is. I checked my answer. Last one. I have 3 and negative 9, negative 2 and 6. Common denominator here, least common multiple is 9. So I can multiply the top by 3. Or I look at the y, negative 2 and positive 6. I also multiply the top by 3. Something seems fishy. Let's see. I'm going to say, I'm going to multiply 1 times 3, or 3 times 1. Multiplying the top by 3, I get 9x minus 6y equals negative 9. And that's, I'm going to call that equation number 3. Now, if I add 2 to 3, I get negative 9x plus 9x is 0. Positive 6y minus 6y is 0. So the left-hand side is 0. 9 minus 9 is 0. 0 equals 0. Yeah, of course. But what does it imply? It means that it doesn't matter. I have infinite solutions for x and y, because this would be equal regardless of the values of x and y. You see, the x and y disappeared, and we only get 0 equals 0. If we had gotten like once before, for example, 4 equals negative 2, I say that's impossible and I don't have solutions. But if I have the same number right and left, I have to say infinitely many solutions. And you can make up some solutions. You can say, okay, what if y equals 0? I get x is negative 1. What if, say, x is 1? I get 3 minus 2y is negative 3. So negative 2y is negative 6, and y would be positive 3. 3 and 3 would be a solution. Or negative 3 and 3 is a solution. I said if it's 1 and negative 3, right? Why am I confusing myself? I said if x is 1, you get 3. So 1 and 3 is a solution. It's one of the solutions. 1 and 3. Right? Yeah, 1 and 3 is a solution. And you can pick any value for x or y and find the corresponding value of y and x, or x, and you get a solution. So there are infinitely many solutions. Okay, so that's the elimination method. You make the coefficient of x in both equations or in y in both equations either equal or opposite. Opposite is, if you make them equal, you subtract the two equations. If you make them opposite, you add the two equations. So you get rid of one of the variables very easily, solve for the second, and then substitute to get the value, like we did here. I hope it was clear. I'm sorry for the negative here that I messed up, but again, it's easy to fix. Okay. Now we have two more questions. I think we said we are going to do the odds. We can do both. I think the time is not, didn't take as I expected. A student bought 3 boxes of pencils. That's important. And 2 boxes of pens for $6. He then bought 2 boxes of pencils and 4 boxes of pens for $8. Find the cost of each box of pencils and each box of pens. Okay? So we have to define two variables, one for pencils, one for pens. It doesn't matter what letters you use. Again, I cannot use P because both of them starts with a P. So we can say, for example, X, let X be. Now, be careful. They want to know the cost of each box of pencil. Okay? So how do I define my variables? I say let X be the cost of one box of pencils. Notice that's what I need, the cost, not the number. The number is given to me, 3 and 2, and then 2 and 4. So one box of pencils, and let Y be the cost of one box of pens, just to save time. So now the first sentence says, a student bought 3 boxes of pencils and 2 boxes of pens for $6. So we are talking about the cost. Okay, so I say, okay, if each box of pencil cost X dollars, 3 of them would be 3X. And if each box of pens cost Y dollars, then 2 boxes will cost 2Y. And the total cost, they tell me, is $6. That's how you write it. And then they tell you, he then bought 2 boxes of pencil that cost 2X and 4 boxes of pens, that's 4Y, and that cost him 8 or her $8. And now we have 2 equations in 2 unknowns. To solve using elimination, and even if they don't tell me, I would say elimination is easy. Why? I don't have a variable with a coefficient of 1, even though I can make one, because the bottom equation happens to be all the coefficients on the right-hand side are even. So I could have divided it by 2 right and left and get X plus 2Y equals 4, and then say X equals 4 minus 2Y and substitute it here and get substitution, use substitution. But it's easier to use elimination. If I look at the X, 3 and 2, the least common multiple is 6. So I have to multiply the top equation by 2, the bottom by 3 or negative 3. That's a lot of work. I'm lazy. I'm going to look at Y. Oh, 2 and 4. 4 is twice 2. So if this equation is number 1 and this equation is number 2, I'm going to multiply negative 2 by equation 1. Why? Because when I multiply by negative 2, this guy would be negative 4y. So when I add it to the positive 4y, they cancel each other. So when I do that, the first equation becomes negative 2 times 3 is negative 6x. Negative 2 times 2 is negative 4y. And negative 2 times 6 is negative 12. And then I'm going to consider 2 and 3. Add them up. So equation number 2 plus equation number 3 gives 2 minus 6 is negative 4x. 4y minus 4y is 0. And 8 minus 12 is negative 4. Wow. Negative 4x is negative 4, so x is 1, right? I'm going to divide left and right by negative 4, and I get x equals 1. X equals 1. Then I'm going to substitute in any equation. So if I substitute in the first, I'm going to say 3x, meaning 3 times $1, plus 2y equals 6. I'm going to subtract 3 from both sides. So I get 2y equals 3. Then I'm going to divide by 2 both sides. So I get y equals 3/2 or $1.50. And this one is just $1. So x, the cost of x. So you can, instead of writing x, you go back and you say the cost of one box of pencils is $1. And the cost of one box of pens is $1.50. It's better to write it in terms of boxes instead of x and y, but for time, I'm just skipping that. If you substitute, say, in 1, you say 3 times 1 is 3, and 2 times 1/2 is also 3, so 3 plus 3 is 6. Or you can say 2 times 1 is 2, 4 times 1.5 is 6, and 2 plus 6 is 8. Very easy to check out. Okay, last one. It says a farm raises a total of 200 chickens and pigs. The number of legs of the stock in the farm totals 520. How many chickens and how many pigs are in the farm? Now we need to know how many. So when I define my variables, it's a number, not a cost like the previous problem. So how do I do it? I say let, well, I can use C and P for chickens and pigs. Let C be the number of chickens in the farm, or just the chickens, and P be the number of pigs. That's how you define them. Don't say let C be chickens and P be pigs. I hate that. Okay? In math, you have to be very specific. In science in general, math, science, engineering, you have to be very specific. Later on, if you just say C is chickens and P is pigs, you don't know, is that the number or the number of legs or the cost or what is it? What does it mean C is chicken? C is not chicken, C is a letter. But you say C, let C be the number of chickens. So when I get a C, I know, oh, that's the number of chickens and P is the number of pigs. Or whoever is grading my homework or test understands what I'm saying, right? Be very specific. Again, I cannot overemphasize that. Write a system of equations and solve using elimination again. Okay. The total number is 220. So C plus P is 220. Couldn't be any easier. The total number of chickens and pigs. Number of chickens is C. Number of pigs is P. So the total number is C plus P. And that is given to me as 220. The second one is the trick. The number of legs of the stock. Well, the chickens have 2 legs. So if I have C chickens, that's 2 times C legs. But the pig has 4. So if I have 4 pigs, if I have a pig, it has 4 legs. So the total number of legs is 2 for each chicken and 4 for each pig, and that is 520. The least common multiple of 1 and 2 is 2. 1 and 4 is 4. So again, to make it easy, I'm going to multiply equation 1 by either -2 or -4. If I make it -2, I get rid of the chickens and solve for the pigs. If I make it -4, I get rid of the pigs and calculate the number of chickens. It's easier to say -2 times 1, right? 2 multiplying by 2 is simpler than 4. So if I multiply the first equation by -2, C times -2 is -2C. P times -2 is -2P. 220 times -2 is -440. 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 220 times -2 is -4 Now I don't need to look at 1. I already multiplied by -2 because I don't want it. I want 2 and 3. And what do I do with them? Of course, add them up. So 2 plus 3. 2c minus 2c is 0. 4p minus 2p is 2p. 520 minus 440 is 80. Dividing by 2, I get p equals 40. Then I substitute, say, in 1. Substituting in 1, I get c, which I don't know, plus p, which is 40, equals 220. So I'm going to subtract 40 from both sides and get c equals 180. So the farm has 40 pigs and 180 chickens. Now I can check either equation. Of course, 40 plus 180 is 220. So let's substitute in the second one. Excuse me. C, I have 2c. If c is 180, so 2 times 180. And p is 40, so 4 times 40. I add them up, I get 520. So I check my answer and I'm done. So you see, the method of elimination, usually it's easier, especially if I have the coefficients. One is a multiple of the other. Okay, and I can use that to eliminate one of the variables, solve for the second, and then again go back and substitute in the other equation to get the value of the second variable. And that's basically it for the method of elimination. I hope it wasn't that bad. And again, as usual, if you have any comments, please let me know. If not, then I'll see you when we do graphing of these types of equations. And we'll do that tomorrow. And hopefully we'll be done with this part of the course. We'll move now to fractions and percents and more interesting and nice stuff. Okay, thank you very much for watching. Have a great day. Bye.